Okay, this is day 9 of the second learning packet for the math section. And we're starting off with another task, and it talks about using the Pythagorean Theorem. So this is continuing from yesterday's practice with Pythagorean Theorem. And we see a football field. We have two players. One is running with the ball. The other one is chasing after him. And we need to know how far they ran during these plays. Okay, so Watson is shown by this W, and then Bailey is shown with the B, and it says that here. All right, so then the first part is, can we use, or how can we use the Pythagorean theorem to figure out how many yards Watson ran? And that's this line that I'm highlighting now. Okay, so how long is that, or what's the length of that line? So can we use the Pythagorean theorem to figure that out? Okay, so we have the width of the field. We know the length of a field. And we know that each of those tick marks along the length is 1 yard. So I think we have enough information that we can use to find the Pythagorean, or to find this distance. So we need a right triangle. Okay, so when I first looked at this, I was thinking we need to connect these 2 points and make a triangle, but that's not going to help us because we don't know if that's really going to be a right triangle. So the only way we really know is if we draw a line from the W straight down to the sidelines. And now, so let me actually highlight that as well. So it's going to be this one, and then we're going to use the edge of the field. Okay, so since we went straight to, or perpendicular to the sidelines, then we know that this is a right angle. And as long as we have 2 lengths of the sides, we can figure out the third. So the side that we're looking for in this case is going to be the hypotenuse, or side C. So can we figure out the lengths of the other sides? And if we can, then we can figure out that side C, or the distance that he ran, which is going to be for part B. Okay, so part A is just how can we use the diagram. So just what we're talking about here. We make a right triangle, and we know it's a right angle because we're perpendicular to the sidelines. So yes, we can use the Pythagorean theorem. All right, so I need to know A and B. So B is going to be fairly straightforward. So we're starting off at the, looks like 2 tick marks before 10, so at the 8-yard line. And then we ended up, so 8 to the 50-yard line is 42. Okay, so I'm just going to add this up. So B, distance B, and you can show your work over here, but I'm going to try to keep it on the same page so we can see what we're doing. So side B, so we have to split it up into 2 halves because that's how a football field is. So from 8 to 50, that's 42 yards. And then on the other side of it, we're going all the way down to the 1-yard line. So that's 49 yards. So if we add that together, then we will get 91 yards. Okay, so 91 would be the length of B. And then we have to figure out the length of A. So this is going to be a little bit tougher. The information that we have is the field is 53 1/3 yards wide. Okay, so looks like this is about 1/3. So this is 2/3 of that. And then this is like 1/2 of a third. So I'm going to figure out a third. So 1/3, what is 1/3 of 53 1/3 yards? So again, we're approximating. It says to be, to approximate, so we don't have to be exact. So I want to know what this distance, just 1/3 of the field is, because then I can use that to figure out the side length of A. So I need to know 1/3 of this 53 1/3. So basically, it's like 53.33 repeating divided by 3. So what is that? So again, just use a calculator, 53 and a third. So 53.3333. I mean, just use as many as you can. You know, it's going to repeat. And then divide it by 3. Okay, 17.78. I'm going to say 17.78. 17.78. So that's a third. So we have, so A is going to be 2 of those. So 17.78 times 2, because it goes, right? So we're one third, so 1/3 and another third, and this is like a half of a third. So I'm going to do 17.78 divided by 2. Okay, so let's see if we can figure that out. So just before we do this, before we use a calculator, there's a lot of decimals. It's really easy to make mistakes. Let's get an idea in our heads what it should be. So if 53 is the full distance, half is like 56 and a half, or 26 and a half. So maybe around, 40-ish, a little bit less than 40. So that's where our answer should be. So let's see if we can get that. Okay. So we have 17.78 times 2. So 17.78 times 2. That's 35.56. And then we need 17.78 divided by 2. That's that extra little piece. And then we're going to add that to that 35.56. So 44.45. So this is 44.45. Okay, so that's the length of A. So again, we figured out a third of the field. So looking at side A, so it's 1/3 and another third. So that's why we multiplied what we found, the third, by 2. So we multiplied by 2, and then a half of a third, which is really a sixth, is this part right here. So if we add all that together, we get 44.45 yards. All right, so I know that seemed like a lot of work, but now that we have it, we can definitely use that to find the length of side C. So let's take that to our scratch paper. So again, let me just draw this triangle. So we have this, and then this, we just calculated that to be 44.45, and this was 91, and this is what we don't know. Okay, so just make sure. Always double check. All right, so Pythagorean Theorem, a squared plus b squared equals c squared. A was the 44.45 squared plus 91 squared equals c squared. So 44.45 squared is 1975.8. So 1975.8. So big numbers. And then 91 squared. 91 squared. 8281. Okay. So let's add those together. So 1975.8 plus 8281. 1975.8. 1975.8. So we get 10,256.8. 10,256.8. And that equals c squared. So remember, our final step is to take the square root. Okay, so again, lots of big numbers. Probably doesn't really make any sense, right? We have no sense of these size of numbers. So let's just go back to our original diagram. The distance, okay, so let's be kind of realistic here. Is it going to be, way over 100 yards? I mean, did he run from the parking lot all the way to the other end zone? No, he's still on the same football field. So it should be, if anything, maybe 100. It could be more than 100 because we're going diagonally. If we go straight across, then it'd be 100 yards, but going diagonal, so could be a little bit more. So our reasonability check, we should get something around maybe 100, close to it, a little bit more, a little bit less. So we have this big number, 10,256.8. And we're going to take the square root of that. So we get 101.3. So 101.3 yards. So that's the answer for part B. So how many yards did Watson run? 101.3 yards. Okay. And then the last part is, which player ran further during this play by approximately how many more yards? Okay, so we just found out what Watson ran, so 101.3. So how much or how far did Bayley run? So let's highlight that one in green. So he starts off in the end zone, it looks like, but in the description said he intercepted at B, so around the goal line. So again, these are all approximate. So let's just highlight that in green. And let's make this, as easy as possible. If he really is at point B, then he's a couple of yards into the end zone. So let's see if we can figure that out. So let's just approximate maybe let's just say 2 yards into the end zone. And then he stopped 1 yard short of the other goal line. So that would be, so if he was 1 yard over the end zone on where he started, then that would be 100 yards. But he started 2 yards over, so that would be 101 yards. Okay, so let's make sure we understand. Okay, so from this point to this point out here, okay, this distance is 99 yards, right? Because it says he's 1 yard short of the goal line. So 99 yards plus those 2 extra yards, that would give us 101. Okay, I'm going to erase that just to save some space. Okay, so approximately 101 yards. But looking at point B, he could be 3 yards into the end zone, or just a little bit over 2. So we don't know exactly. So looking at our numbers, how would we answer part C? Which player ran further during this play by approximately how many more yards? Honestly, I would answer it by saying both players ran about the same number of yards. And really it is 101.3 and 101. It could be 101.3. We can't see exactly where he started. And then again, this is all estimates. So we don't know exactly where this distance for A, right? We made a good guess, but it may not be exactly right. So we're doing the best we can. And based off of that, I would say they ran approximately the same amount of yards. Okay? And then, your proof is all of this work, showing the Pythagorean theorem. I mean, really, the ultimate goal is to kind of look at a diagram and see in a real-world situation, how can we use what we learned in math class to figure out something in the real world, right? So this is something that people do, whether it's using a computer program, but yeah, that's how they know how many yards they ran. I mean, it's all done with Pythagorean theorem. Okay, so moving on. some more practice with Pythagorean Theorem. Just keep in mind that you're not always solving for side C or the hypotenuse, so just be careful with that. It's really easy to just keep using the same kind of method over and over, but you're going to get the wrong answer. So I'll do two examples. I'm going to do number 1 and number 2, which will show us that the procedure is a little bit different. So number 1, so look at the right angle, find the right angle, and remember the side opposite is our side C for when we use the Pythagorean theorem. Okay, so side A and B you can choose. It doesn't really matter which one you say is which. So I'm going to say 7 squared plus 3 squared equals C, but it's called D for this problem, so just label it with what we have, so D squared. So 7 squared is 49 plus 9. Okay, so 7 squared, so make sure just always double check your work. And if you don't have a calculator that does squared, like this one, it has, if you can see it on the bottom left, x squared. If you don't have that on your calculator, what can we do? You can just do 7 times 7. So just make sure that you're typing it in right. So we have 49 plus 9 equals d squared. And then when we add those together, we get 58 equals d squared. Square root of both sides. So square root of 58 is 7.6. It says round to the nearest tenth, so 7.6 equals D. And we have units, okay, so this is miles, so 7.6 miles. Okay, so that was solving for the hypotenuse. Now, number 2, look at that right angle, and opposite that is side C. So we're given side C, we need to find one of the other sides. So the procedure is a little bit different. So still the same formula, a squared plus b squared equals c squared. So this time a is 4, so 4 squared plus b, but they're calling it h, and then 18 squared. So we have 16 plus h squared equals 18 squared. And then solving it, we have one more step before we take the square root. So we subtract 16 on both sides. We get h squared equals 308. Now we can take the square root. Okay, so square root of 308 is 17 point, remember we're rounding to the tenth, so 17.5. So h equals 17.5, and our units are feet. Okay, so look at these two examples. Do we see the difference in how we did this? So when we're solving for C, we square the other sides, we add that together, then we take the square root. If we're solving for B or A, then we have to, there's that extra step of subtracting a number from both sides before we can take the square root. So just be careful of that. Okay, I believe this is our last piece. Okay, so this time we have a square root is our problem, and it's a square root of 23. So we should already be thinking that square root of 23 is not a perfect square, so we're going to get a decimal. We should also be thinking this is an irrational number, okay? And then let's see what we have here. So the top left, it says think about perfect square roots. Which two perfect square roots is the square root of 23 between? Okay, estimate the value. Can you estimate again to get closer? So we've done this in class. And then show it on a number line. We've also done that. Okay, so let's think about, so square root of 23. So we want to know square root of 23. All right, so again, if we have our multiplication table, we can look at the diagonals and then find two numbers that 23 falls between on that diagonal. Okay, so if you have one, please do look at it. I don't have one in front of me, so I'm picturing it in my mind. So it goes 9, and then 16, and then 25. So if I have the square root of 25 on one side and the square root of 16 on the other side, okay, so what is the square root of 16? Okay, that's 4, and the square root of 25 is 5. So the square root of 23 is going to be in between 4 and 5. Okay, so we know that, right? And that's all we have to do for that. And then it says estimate the value. So can we get a little bit closer than just somewhere in between 4 and 5? So let's look at this again. So is it going to be closer to the 4 or closer to the 5? So look at that number, 23. Is that closer to 25 or is it closer to 16? So it's much closer to 25. So I'm going to guess that it's, so I'm going to say it's approximately 4.9. Okay, so is that right? How would we check? Okay, so it's not 5. Okay, so if I take 4.9 and I multiply it by itself, I can check to see if that's 23. So if I do that, 4.9 times 4.9, I get 24.0 almost. So 4.9 times 4.9 is 24. So that's a little bit too big, right? So let's just cross that off. Let's try 4.8. Okay, so 4.8 times itself is 23.04. 4.8 times 4.8 is 23.04, which is close enough to 23. So our best approximation is 4.8. Okay, so it is kind of like a guess and check, but we can make our first guess a lot closer by looking at these numbers on this left side here. So we see that it's definitely closer to the 5. Otherwise, we would have to go, if it was true guess and check, we would start off like 4.1 and then 4.2. But, we could do it much quicker based off of what we already know. All right, and then show it on a number line. Again, it's going to be kind of the same as we did in the top left. So our end points are 4 and 5. And actually, I'm going to just put the square root numbers above that. So those are the equivalent numbers. Square root of 25 is the same as 5. We're just writing it in a little bit different way. And then if we can split this up into 10 sections or tenths, then we can plot that 4.8. So can we do that? Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's just be approximate. Okay, so let's plot this number. So at 4.8 is the square root of 23. And that's it. How do we know our answer is correct? So how do we know? Well, this process that we did up here. We multiplied it by itself to make sure that it equals 23. Okay, so you could just write that out. Just explain what we did. And that is the end of this day.